People think that the events that changed the world were things like wars, natural disasters, or vast population movements. But according to chaos theory, tiny things change the world. In chaos theory, the butterfly effect is the idea that small things can have non-linear impacts on a complex system. This concept is often imagined with a butterfly flapping its wings in Brazil and causing tornado in Texas. It is obvious that a simple act like the butterfly flapping its wings cannot cause a tornado. However, such small events can still serve as a catalyst that act on starting conditions. What makes chaos theory interesting is that it makes us question, how good are we at predicting future? One of the main pillars of science is determinism, the possibility of prediction. In the late 1600s, Isaac Newton laid the foundations of differential calculus, unraveling the laws of mechanics and universal gravitation. Given a mechanical system, be it the solar system or a bicycle, we can write down a differential equation governing the motion. If we know the present position and velocity of the system, this differential equation can be solved in order to determine the future. This made people feel that everything is predictable and created the idea that future is already fixed and all we got to do is wait for it to unfold. But Newton realized that it was strenuous for him to solve a problem involving more than two bodies. It was later confirmed by Julius Henry Poincaré that there is no simple solution to the three-body problem. Poincaré discovered a chaotic deterministic system which laid the foundations of modern chaos theory. Although the concept of butterfly effect has been long debated, the identification of it as a definite effect is credited to Edward Lorenz. For some years, Lorenz had been studying simplified models which describe the motion of the atmosphere in terms of ordinary differential equations having a small number of variables. Edward Lorenz was trying to make a basic computer simulation of Earth's atmosphere. He analyzed a differential equation in a space of dimension 12. He made the computer print out each time step as a row of 12 numbers to analyze how they changed with respect to time. After completing a run successfully, Lorenz wanted to rerun the simulation. Initially, he entered numbers as they were, but during the rerun, he rounded the numbers. For example, he rounded 0.506127 into 0.506. He ran the simulation again and went out for a cup of coffee. When he returned about an hour later, the computer had generated about 2 months of data. But the result was surprising. He found that the new solution did not agree with the original one. At first, he thought that the computer was faulty, but later he realized that it was not. He simplified the equation even more and arrived at a model of convection. A thin layer of viscous fluid is placed between two horizontal planes, set at two different temperatures, and the objective was to describe the resulting motion. Lorenz obtained a three-dimensional differential equation. Here, x represents the intensity of the convection, y represents the temperature difference between the ascending and descending currents, and z is proportional to the distortion of the vertical temperature profile of linearity. But again, he observed the same behavior. Even if he changed the numbers just a tiny bit, the results changed completely. He realized that if the real atmosphere behaved in the same manner as the model, long-range weather predictions would be impossible. Since most real weather elements were certainly not measured accurately to 3 decimal places. In simpler language, he theorized that weather prediction models are inaccurate because knowing the precise initial conditions is impossible. A tiny change can make the results completely useless. To make the concept easier to understand for non-scientific audiences, Lorenz began to compare it with a butterfly. He elucidated that a butterfly has the ability to create changes which, while not creating a tornado, could alter its path. A flapping wing represents the minute changes in atmospheric pressure, and these changes compound as the model develops. Lorenz's system displayed what's known as sensitive dependence on initial conditions, which is the indication of chaos. The system is completely deterministic, so if you input exactly the same initial conditions, you would get exactly the same result. The problem is that the system is chaotic, so any difference in initial conditions, no matter how tiny, will be exaggerated to a totally different final state. Even our solar system is not predictable. A study found that its behavior as a whole is chaotic. The systems we have always thought as of representatives of order are actually unpredictable on larger timescales. So, coming back to the question, how good do you think we are at predicting future? My answer would be not as good as we have always believed. It becomes more challenging as we try to predict further in future, and past a certain point, predictions are no better than mere guesses. Many examples exist of instances where a tiny detail led to dramatic change. In each case, the world we live in could be completely different if the tiniest details had been changed. Number 1. Rejection of Adolf Hitler's application at Academy of Fine Arts in Vienna. In early 1900s, young Hitler applied for art school and he was rejected. It is estimated that this rejection went on to shape his metamorphosis from an aspiring artist into evil. We can assume that a great deal of tragedy could have been avoided if Hitler had applied himself to art rather than genocide. Number 2. The bombing of Nagasaki. The United States initially planned to bomb the Japanese city of Kuroko with the munitions factory as a target. On the day the US intended to attack, cloudy weather conditions prevented the factory from being seen. The airplane passed over the city 3 times before the pilots gave up and decided on Nagasaki as the target due to improved visibility. The implications of that split-second decisions were monumental. Just imagine how different history might have been if the day had not been cloudy. Number 3. The Cuban Missile Crisis. A Russian Navy officer named Vasily Arkhipov, who has been called the man who saved the world, may be the reason for global peace. During the Cuban Missile Crisis, the captain, Savitsky, prepared to launch a nuclear torpedo. Everyone agreed with him except Arkhipov. If the torpedo would have been launched, the result could have been worldwide nuclear holocaust, as the countries would retaliate and spread the conflict. Yet, within an overheated underwater room, Arkhipov exercised his veto power and interrupted the launch. Without the courage of that man, our world would have been unimaginably different. These examples are enough to explain how fragile the world is and how drastic the effects of tiny events can be. Many simple and tiny details changed me drastically. What about you? Has any insignificant tiny situation ever changed your life? Let us know in the comment section. Thanks for watching.